Welcome to the fifth episode of the Hitchhiker's Guide to the Industrial Metaverse. I'm super happy that we've got two guests from NVIDIA, friends, and Paul Katzinger and Brian Klobuchar. Paul is the director of Omniverse Exchange at NVIDIA, and he's focused on tooling for real-time and true-to-reality simulation, and he was with Amazon, Disney, and Microsoft. So big thank you for being here. And also Brian Klobuchar, he's a member of the team of Paul, and he's a specialist for spatial AI, generative AI, and neural reconstruction. And he started off at MIT and went over to Raytheon and is now with NVIDIA. And I'm so happy that you join for our episode on generative AI.
So happy to be here. This is awesome.
Yeah, thank you very much for having us.
Yeah, and really great that you're here. And we'd like to discuss generative AI. I have brought a little clip as an introduction. Where is it? Haven't seen it. Just a sec.
While you're looking for that, it's good to see some people in the audience, Gavin and Richard.
Yeah. Hi guys, welcome. So here it is. I'll leave the sound off. But we in the industrial metaverse, we need full digital twins in order to train and get our autonomous robots going, and with Omniverse and NVIDIA, we've got like this whole environment to train but our sensors, and so we need like the virtual environments, and here is where the generative AI comes into play. And with that, I'd like to ask Brian, what's generative AI, and how does it relate to that?
Yeah. So I'm really glad you showed that clip, because as a motivating example, let's say you do have these AMRs, autonomous mobile robots, that you want to train to use in your factory or warehouse or anything like that. You can go through traditional AI approaches to gather training data to train whatever particular task you want them to do. But let's say that there is something novel or unique, like a long tail event, that you want to inject into this training. You're not going to go and spill oil all over your warehouse just to gather enough training data to figure out how you're going to respond to that. But with techniques like generative AI, you'll be able to tell your metaverse, like, put a spill in this area, and then you can run simulations to see how you react now, what you need to do to fix that to react in a good way that allows you to stay productive. So if I can just dive into some of the differences between traditional AI and generative AI, when you think of AI over the last decade or so, you think about advances in pattern recognition, in classification, and in prediction for decision making. Like, we know that a busy season's coming up. How much inventory do we need to order? And you can use historical data to predict what you need in the future. What generative AI allows you to do is to generate new content, like the spills we talked about, or new designs, or maybe even like new paradigms for how you want to organize your factory, that a person might be able to think of, but it could take a long time to figure that out. So generative AI allows this potential for novel content to come in. But it's not all perfect yet. There are hallucinations, and I'm hoping we can talk about that a bit more. But hallucinations are just things that seem plausible to the AI, but they're not really real. It's like when you talk with one of your kids, they might talk about something that conforms to their worldview, but it's not exactly how reality really works.
That's with ChatGPT as well, right? When you ask something and it doesn't have to be true, right? Kind of.
Right,
But
right.
sounds like
It might just sound true, or when you generate an image. One of the things that was really hard for a long time was generating images of hands. You would see if there were hands in an image, it could have 6 fingers or 4 fingers or like multiple thumbs. And it's just because there wasn't enough training data to really generate hands properly. But like to the AI, it still seemed like this was a reasonable thing to do.
Right, right.
One other thing, just for laying the groundwork, when you hear about generative AI, you'll hear a lot about foundation models. And those are just neural networks that have been trained to accomplish a large number of tasks. And you'll also hear about multimodal models, which can do one data type to another data type, like text to image, text to audio, text to video, those sorts of things. And one other point, just laying the groundwork, is that's really exciting about this is the customization that you can do with these models, and how they really are getting to a great point where they understand the context of your question. One of the easy to understand examples of this is when you ask an AI, what's an egg yolk? A perfectly fine example is to say it is the yellow bit within an egg. And that makes sense when you're asking from like a learning perspective. But if you're a nutritionist, you would want to know like what's the cholesterol content of the yolk relative to the white. If you're a biologist, you'd want to know like how does the yolk assist in reproduction? What's its role? Like how does it work from a cellular standpoint? Biology is not my strong point, so hopefully I end up with every biologist you watch. But the context there is really important, and I think that's one of the really, really powerful things about generative AI, and one of the interesting challenges to solve is like making sure that the context comes across, because that's what makes it most useful.
Same for Python, right? For as a programmer, you're thinking in programming language, and as a biologist, you think it's a snake, right?
Oh yeah, that's great. Yeah.
That context is interesting from an industrial point of view too, because so far most of the generative AI stuff we've seen is text to something or image to something. It's all been trained on bodies of text and large volumes of images, and ultimately we're going to want this to be trained on something similar to the real world, like a simulation of a 3D space that understands where things are in relation to each other, the different characteristics, like vehicles can go on floors, but they shouldn't go on ceilings, and that kind of stuff, and getting a sense of the spatial awareness. And so that context will shift. And as we get to a point where these virtual worlds can be more sort of sensorially correct, we can train our AIs on the sensorially correct. So like right now it's doing a great job with vision. Like we can take a bunch of pictures of the world and then train vision recognition AIs. But that oil spill example from the beginning, one is we should see a vision of there's oil on the ground and it looks different than other things. But the other one is to be sensorially correct. When the robot goes through it and the wheel slips because the friction's different, that should be part of the training data, right? We should have that sensor input as part of the context of the scene.
So the physical attributes basically are the context, right?
Yeah, it's all so you have cameras, LiDAR, friction, weight. Like if a robot picks up a box, that the grippers have some sort of friction against the box. Right. And then if they squeeze too hard, the box has a crushability. And if they lift it, that box might have a mass that's slightly off center. And so it's got to account for all of those things ultimately. So you need to have like this notion of simulation ready assets and a full scene in order to train up the future AIs that will exist.
Right. And sound probably as well, like scratching if you're right.
Totally. That's a good point. Yeah. Right.
Yeah. Okay.
Yeah. Even for like listening to a motor or an engine or a conveyor belt or something like that, if the sounds change. Yeah, that's an interesting one.
You want the full blown digital, holistic digital twin.
Yeah. there's definitely the productivity aspects and potential for equipment damage. There's also the safety concerns. Within a factory, you want to make sure that your workforce can be productive and be safe doing so. And if you have some sort of hazardous material that is flammable, for example, you want to make sure that that doesn't get near any heat source where it could ignite, or if it's potentially like toxic, you definitely don't want that spilling around where you have a lot of people or a lot of things that can absorb it and cause any safety concerns. So there's a lot of value in having these sorts of platforms in place where you can do this analysis and make sure that you can be productive and that your workforce can be safe.
But how do you generate this with AI? Can you maybe tell a little about the underlying techniques and how? I mean, it's a very young field, right? When did it start and what? Yeah, if you can
Yeah, generative AI has been around for a while. Like in terms of people have been trying to do this. But it's really taken off in the last couple of years, and transformers are the big technique that has really helped with that. Transformers are a technique that allow you to work to understand sequences of data, and not just restrict your understanding to like what's closest to each other. But there are other techniques as well. There are diffusion models. We've heard about stable diffusion, where you have a text prompt, you can generate an image, you can add noise and then remove noise, and then that helps you generate new content. There were general adversarial networks, or GANs, that do the same thing, where you have one network that is like a student trying to learn how to generate something, and then another that, there are different ways to describe it, but you can think of it like a trainer or a coach to help it improve. And so there are lots of different ways that you can do generative AI, and it really depends on the use case, what you're trying to do. But one of the cool things about the foundation models and transformers is that you can just take as much data as you can get your hands on, and transformers have allowed self-supervised learning to occur. So you don't need the expensive human labeling process. You can just have this massive data, train your algorithm, and then evaluate it. And one of the cool things is how you can customize this. So for example, if you're a manufacturing company, that there are you have public data that you have access to, but you also have your own proprietary data. You can train your algorithms with your proprietary data. So you can ask questions of a generic sense, like, what's going on externally in this market, or like, help me draft an email for this purpose. But you can also bring in your data to ask questions about what's going on in your facility. Like in this work cell, like what was the pressure reading on this particular sensor? And you can't get that from publicly available data, but if you can tie in your data, then now you have this valuable resource that is customized to what you need and what data you already have. And I think that's really powerful. That's one of the really cool things about these techniques, is the ability to combine both.
Isn't that this pre-trained model kind of thing, where you then train use your own data to advance the training, right? Or how does it work basically?
Exactly. So you have these foundational models that are pre-trained on some data set, and then you can bring in your data and do some transfer learning and some customization to allow it to actually provide you everything that you need. Again, like from a factory setting, the data from your factory, your own documentation, any internal records that you have, and you can also tune them to be consistent with your brand, how you write, how you speak, how your company does all that. It's really powerful. And one other thing that you can do is also language translation. So, we were talking in German a little bit. My German is okay, but it's not.
Oh, it's good. It's good. I heard it. It's very
right. But if you're talking with somebody who doesn't have, who might not speak your native language, like as fluently as you like, especially if it's like a remote repair situation where you have an engineer in one country and then a field technician in another. Then or potentially out on an oil rig or in a factory in another country, and you're trying to help them fix something, then having this real-time translation can be incredibly useful because it can reduce the downtime and help you get back up to producing your product as quickly as possible.
And also this segmentation, right, of the environment that I could like the AI could help me like orient myself basically to know this little screw is like the right one or right, stuff like that, right?
Yeah, segmentation is huge, especially with a lot of the techniques that are coming out now. And there's so much happening in the space. Like 2 months ago, segmentation with certain techniques was an unsolved problem. And then a paper came out and boom, there's a solution for it. So another really exciting thing is how fast the field is moving and how curious people are and how creative people are being in solving these problems.
Yeah, I guess Paul. I mean, you're in touch with lots of AI related people, right? It's awesome what's happening, right?
And the thing that's really struck me about this is that I'm used to coming from like the engineering world, right? Like product, and you're incrementally improving a product every time. You're like, what's the minimum viable product? Let's add one more thing, just keep going and minimally improving. And what I've noticed in the AI space over the past, I guess, 8 years or so that I've been digging into it, is it comes in these leap functions where all of a sudden there's this whole new capability that nobody, what the heck? And then so what I found is that as like practitioners who are going to use AI and find ways to incorporate into their work, you've just got to stay ever curious and ever like willing to learn about what the new thing is and figure out. You have to have this experimental mindset where you're like, what is this thing? How could it possibly apply? And it doesn't work in 10 ways, but in 2 ways, it's amazing for my workflow. And then I like, okay, great, I better adopt that. And boy, if you don't just keep that attitude of like, what the heck is next, and be willing to be surprised, to be willing to think in a new way when it sort of opens up, it's good. So for example, with ChatGPT, I guess I really started digging into ChatGPT in earnest probably in November or so of last year. And I was like digging into it and starting to figure out what prompt engineering was about and digging into it. And I realized that I was using my like programmer mindset with it, which is actually helpful in a bunch of ways. But then there's other ways where just like, I had assumptions about what it could do and what it would deliver. And I just needed to like throw those away and just try things that I didn't think it would do. And many times it wouldn't do it, but many times I was like, whoa, that's actually pretty decent. Let me go refine and tweak that. Right. So I've just been shocked by like the pace of change that's relevant to be used now. Like there's in the research community, a lot of changes have been happening for a long time, and this has been building, but it's sort of like become available to all of us, which is nice.
Yeah. The experimental mindset, I think, is key. And especially with tools that are so available. We talk about replanning an entire factory, but that's really expensive, and that doesn't happen very often. But if you have these tools at like an individual level, at a work cell level, then people can come in and use them to do their job better. And sometimes like those little improvements are all you need to make your life better, make the products better, make your workforce happier. So yeah, I think the fact that non-developers can go and use these tools and just experiment, iterate rapidly, communicate those ideas, test out what works, what doesn't. It's just amazing. I can't wait to see what all of the ecosystem does with these tools.
Yeah, this is what if mindset kind of. What if I would like have this and this element in my factory and place this here and just let the whole thing generate again and try it and simulate it. I think this has a lot of potential to think try out a lot of different variants and generate like a whole bunch of scenarios, and then still do the right decision or decide for myself as a planner, because that's important. We don't want to have the AI do everything, but just help us to take the best decision from my point of view. Or what do you think, you guys?
Yeah, we've got this notion of variance. Like when you're thinking, if you put this into the 3D world, I guess, this notion of variance where so far, like a designer might have said, I want the building to look like copper clad, or I want it to be like silver, or I want the windows to be tinted. And they would create variants. And then people reviewing the building could like flip through the variants and look at the different look, and they could talk to their clients and figure out which is the most appealing. What I've found so far is that using variants with AI results is a great way to go, because I'll say, for example, give me the skybox, give me the scene of the space around my warehouse, and give me 3 or 4 variants, and it gives you 3 or 4, and you can flip through them, find one that's the closest, and maybe that's good enough. But it gives you a little bit of flexibility to iterate. And then it's almost this sort of like sketching mindset where it gives you a sketch of what you want. And sometimes, given the level of detail you need for a particular part of your space, that's good enough. A sketch is all you really want. You want an indicator that there's shelves and boxes and clutter in this like storage area. And other times you actually want the real stuff, right? Like you want to actually like get the conveyor belt perfectly laid out. So in those cases, you might say, drop me some conveyor belts in there, and you put it there, and then you go, okay, they're not quite right. Let me go in and move them around and position them how I want. And then I can create, again, a few variants that I could use to test out different scenarios. And the other thing is, because it's generative, you get this sort of weird out of your own head inspiration sometimes. Like it'll do things that you just weren't expecting. And you're like, actually, that's an interesting vein to go down. And it might prompt some other ideas, like the spills on the floor you might think of, but you might not have thought of the hazardous spill on the floor with fire coming out. You go, oh wait, oh yeah, that's a good point. We've got to care about the fire safety in this particular space or whatever.
Yes,
so
it's more creative, maybe. Yeah.
Yeah. So I like the ability to have it like almost like sketches and give you some options.
Yeah.
And then, by the way, those options can come from generative AI, but they could also come from procedural algorithms that are building up scenes, or they could come from humans who are making up ideas they might want to have. And you might have a collection of these variants from all sorts of sources. And then you can step back and look at them all and figure out how you might want to use them and pick and choose and refine and, go from there.
Bringing together the tools and have a tool belt kind of thing.
Yeah.
That's good,
yeah. And on that note, when you think about how you can use generative AI or how you can get started using it, you don't need to replan a whole factory. You can start smaller, and you can actually start with some of the apps in the software that you're currently using. Maybe you hook up a large language model to them, so that way you can have more of a natural language interface with that tool, and just say like, hey, generate me this oil spill here, instead of trying to find a model for oil, trying to find a particular way that the viscosity of the oil, and setting all of these parameters. You can just say, do it. And you don't necessarily need to be a software engineer or have incredible programming skills to do it. So you can hook it up to current apps and get a lot of value from that. And then once you're familiar with those and comfortable, then you can start looking at what new apps do I want to do with generative AI, like generating a whole new product line in your factory for a new product.
It's like democratizing the creation process, right? Kind of.
Yeah.
Because everybody can talk basically, but not everybody can program. So I think
like language is becoming a new programming language. I guess to that end, can I show you a little video real quick that sort of illustrates that point? Okay, let me share my screen if I can here. This is a subset of the Computex keynote that Jensen did a month back or so. I'll hit play. I'm going to pause it a few times. Oh, this is just some fire part. This is before the actual demo I wanted to get to, talking about some of the different Omniverse stuff. Here we go. So here we go. This is using that idea of a large language model, and you say, hey, I have this floor plan in PowerPoint. Can you make it 3D? And this is where you can imagine starting to connect together systems of AIs. So here I've got a large language model that's taking what you've said and converting it into commands. And in this case, it's launching SyncTwin. And oh, wow, that went really fast. Let me back it up just a second. And so in SyncTwin, you can put in a PowerPoint. Here, it's starting to fill in.
Yeah, that is, yeah.
So you got a PowerPoint of your floor plan. And on your PowerPoint of your floor plan, you have different regions. Like this is and you type into it, this is a loading zone. This is a storage area for forklifts. This is an office space. This is a reception area with comfortable chairs, right? And so you draw it in there, and then through SyncTwin, you upload that that PowerPoint into Omniverse, and SyncTwin goes through and it finds all those regions, and it sort of calls different AIs to do the different tasks through this, which is pretty cool. And then, so here it's like taking that floor plan and building the walls around. So you have the warehouse.
It's all like NVIDIA components, basically. No?
Yep, all the warehouse components. And then one of the areas was a forklift loading zone. So what it did was it said, I need a forklift, and it used ChatGPT to say, give me an area that's this big, filled with things like forklifts and shelves and stuff like that. And it took that language, and it then in turn called another AI called Deep Search. And Deep Search will take text and find the assets from your asset repository that are valid. So like if you're building a whole building, you might use a particular furniture designer and certain materials for the curtains and whatever. And you could use text to find assets that are in your library of assets to drop in. So in this case, it used these forklifts that were the forklifts that you are using, and it's dropping them into the scene. And then back here, there's an office coming in, right? So you can see there's an office back in there. Oh, and then the lighting. That was very subtle, but oh, I went back too far. There was a little clip in there about how it gave variants of lighting. Let me see if I can do that one more time.
Oh, yeah. Let's see.
So what you're going to watch is right over here. Well, you'll see the lighting change, and there's these variants here that you can click through, and it'll start to like.
Oh yeah, now we saw it.
Right.
Mm-hmm. Awesome.
So anyway, that sort of gets to what Brian you were talking about this whole like you use generative AI in different little slices of this entire experience, and then I think the power of what you did there, Michael, was to like bring those together, and you'd say like I want to take something from PowerPoint and I want to get it to be real. And it's going to take some procedural stuff and some AI stuff and some direct customer experience
simulation,
stuff.
Yeah.
But I thought that was a really powerful demo where you just like upload a PowerPoint, and from typing text into the PowerPoint, like people were able to bring it through. So it was really cool that you leaned in and really worked on that, Michael. It was awesome.
And thank great working with you guys on that as well. So I think that's a great thing about the Omniverse, that you just have can put together all these different tools, and is it generative AI or your own tool or whatever, and create like this holistic digital factory twin. So yeah, it's awesome to see what.
Well, that is the idea. Like the whole point of universal scene description, like USD, is that you have a language for describing the world and what the scenes look like. And then now it's a question of having a network of tooling to help you bring that together. And that network of tooling includes all your favorite apps that you might want to use, but it could also include all of your favorite AIs, right? It's a network of AIs that come together to work on that scene. And they can either help create the scene, or they can take the scene and then operate on it. So like training your robots is learning from the scene. Training your autonomous driving is learning from the scene. And then there's a creation side and a using side. And I don't know. I'm just excited for tool builders right now.
Yeah,
Like the opportunity space for people who make tools to reason about a digital version of the real world is wide open. Like
yeah,
it's never been.
And OpenUSD, that's just the foundation for it, because the truth basically is in the USD components in this digital twin. So and all these tools can like collaborate and communicate also via these components in USD. So I think that's a real a foundational thing for this holistic digital twins.
Yeah.
Great. Time is already over.
Oh my gosh!
It's so nice talking to you. So I would continue, but I think let's. I don't know. Did we have some chats questions? Well, no. I think that's good. So. It was very, very interesting, and I hope our listeners had also a good overview and what's possible, and I think more is still to come, and we'll start just at the beginning, right? And so thank you all,
thank
you guys, Paul and Brian, for joining. I think it was a really great session, and I hope we can continue working on that together and see where we come. Right.
I love it. And if anybody has ideas for tools and AI based tools, please talk to the three of us anytime. And I'm so interested to brainstorm that with you and figure out where it might go, what the new business models are going to be, and how the tech stacks are going to be built for them. And it's just cool. So reach out, like whole new world. Let's figure it out.
Awesome. And we publish the links and everything still. And
definitely check out Jensen's keynote from Computex. Look at the NVIDIA blogs on generative AI. There's lots of great information out there. Check out how you can use USD to help have that foundation for going forward. Lots of exciting stuff.
GitHub repos for using AI inside of Omniverse if you want to see that. So, it's great.
Great. So thank you again. Also, Janine, Bea, and also Julie, and you guys. It was a great session. And talk to you soon and have a good day.